Bam! Part 2, folks, of the cell membrane notes. Getting in and out of the cell. So let's talk about it. How do you do it? Passive transport, movement without energy. If you are passive, you are not using a lot of energy. If you are active, you've got lots and lots of energy. Kind of like me. All right? No slugs around here. So, getting in and out of the cell. Cells need to take nutrients in and eliminate waste to get them out in order to live. We discussed this briefly during the cell size lab. How do these substances get in and out of the cell? Well, they got to cross the cell membrane. And I alluded to this in the previous video that not everything just crosses it. Some things need to get through the proteins to get there. Okay, cell membranes are something called semi-permeable. See that word right there? Semi-permeable means some stuff passes through. Some stuff, permeable, passing through. Not everything, okay? But some stuff can go right through the membrane into the cell. This means they let certain molecules cross while preventing others from passing. Small molecules can enter and leave the cell freely. Example, water. Water's got to get inside that cell. Large molecules cannot enter and cannot leave the cell freely. Example, proteins and carbohydrates. Structurally too big. They're just too big. Can't do it. So how do these molecules cross the membrane then? Well, passive transport. Movement across the cell's membrane without the input of cell's energy. Remember, passive transport, no energy. Slugs at home, passive. Examples, diffusion, osmosis, and something called facilitated diffusion. Move myself up here for you. And we'll go over here. Now for active transport. You must use energy for active transport. To be active, you have to use energy. So what is diffusion? You've heard it before. You've done it in earlier grades. Diffusion is the random movement of a molecule from an area of high concentration, where there's lots and lots of molecules, very dense, to an area of lower concentration with fewer molecules. Right here, look. It starts in the corner here, high concentration, and disperses throughout the room. Here's a great example of this. Someone in the front of the room sprays themselves with a perfume. You're like, oh, people right next to you are like, oh, it smells good, or it smells good. 5 minutes later, the back of the room can smell it because it's been diffused across. The molecules of the scent are dispersing all the way through. Or, even maybe more potent for you, someone's making bacon in the kitchen. And you're sleeping, and all of a sudden you're like, oh, I smell bacon. Okay, it has diffused towards you to fill up the smell of the house. That is diffusion, the movement of molecules from an area of high to low concentration. When you get to this point like you see here, where they are evenly spaced out, the end result is called equilibrium. See how they're kind of equally spaced out? So it smells the same as it does in the back as it does in the front. Equilibrium. So the rate of diffusion depends on a few things. Temperature of the molecules involved. Molecules diffuse faster at higher temperature. Think of it this way. When it's hot outside, it's summertime, things smell worse than they do in the winter. Just walk past your trash can in the summer on a 100-degree day compared to right now when it's 27 degrees out. The size of the molecules involved. The smaller molecules are able to move faster. Okay, when discussing diffusion, osmosis, and things moving across the cell membrane, you will come across the term concentration gradient. And its definition is the difference in concentration of a particular molecule. Pretty simple. Diffusion will always occur down a concentration gradient, and you'll see that in writing a lot. When the molecules have been dispersed evenly, there's no concentration gradient. Equilibrium has been reached. So until it gets to equilibrium, it is moving down a concentration gradient until it reaches equally or equilibrium. Now to another term you've heard, osmosis. If you've never seen the movie Osmosis Jones, it's great. Great animated movie. You want osmosis? That's what he says. It's a great movie. Osmosis definition, movement of water across a semi-permeable membrane. Okay, you're like, all right, I got that. All right, here we go. We've got water across a cell membrane because it's semi-permeable, right? It's a form of passive transport. Water moves from solutions with higher water concentrations to solutions with lower concentrations. What does that sound like? Well, that's the same definition as diffusion, except for now you're using water. Osmosis deals with water. It's simple. So with the movement of water and liquids coming in and out of the cell, the concentration of the solutions is different. A term called hypotonic solution means that the cell takes in the water or the nutrients or whatever the liquid might be to the point where it blows up and it could possibly explode. And when it explodes, it's called lysed or lysing. Boom, right? An isotonic solution is when it takes in the same amount as it gives off. So it looks like nothing's happening, but it's actually taking in and giving off the same amount of liquid. For example, 1 cup of water in, 1 cup of water out. Over in this one, it's just 1 cup of water in total. It can't get any out and boom, blows up. A hypertonic solution is when it just lets off liquid and doesn't take any in. So you'll see this when you add salt water to cells, which is why you can't drink salt water if you were stranded somewhere. You can't just drink the ocean. If you do that, your cells lose water, become hypertonic, and shrivel up. And then, unfortunately, you're not going to make it. Now to facilitated diffusion. Some molecules diffuse across the cell membrane with the help of proteins. Remember I said they can go in here and they can cross. When they do that, that's called facilitated diffusion. Molecules that are large, charged, and are ions. Okay, here is the key for this slide here. Large molecules like glucose, C6H12O6, that you should all know, enter through the cell special structures called the membrane proteins, which we discussed. Because facilitated diffusion is passive transport, molecules move from high to low concentration, just like diffusion, just like osmosis. And that will bring us to active transport. But for you, that's the end of part 2. Active transport will be part 3, right? So good job. Let me know if you got any questions.